Okay, welcome to the fourth gas processing tutorial. In tutorial 3, what we did was to build a complex steady-state case. In tutorial 4, what we'll be doing is taking a look at some transient cases. So you can see our OLGA window over here. We have a number of different cases. This was the end of our tutorial 2, or our tutorial 3 start, and we'll be needing this case to do tutorial 4. We'll also be needing our completed tutorial 3 for the second half of the tutorial. So, as I said, we're going to be looking at transient cases today. And the first thing that we'd like to do is to just understand a little bit about what the difference is between the so-called transient and steady-state cases in terms of the way that OLGA calculates them. Now, everything in OLGA is technically a transient calculation, and the difference comes in when we take a look in our options at this steady state option here. Now this is actually an option for the steady state preprocessor, and what this basically means is that when this is active, OLGA is going to run a quick calculation across the entire flow line, and it's going to work out approximately what the simulation looks like. What it can then do is to use its transient calculations, and at every point along the pipeline, to step time forward. And in that sense, it's still a transient tool. What's going to be different about our purely transient calculations is we're going to be changing these initial conditions that are fed into OLGA's transient simulator. So what we'll ultimately be doing is to turn off this steady-state preprocessor and look at how we can simulate firstly shutdown and then restart within OLGA. So the first thing that we're going to do is to just duplicate our tutorial 3 case, and we're going to call this tutorial 4 start. Okay, and we're going to be editing this from now on. Now, what we can do within our tutorial 4 start is to very quickly go into options, and we're going to be running a transient calculation. So we're going to turn off our steady-state preprocessor. Okay, we're then going to go into our integration, and what we're going to do, as this is going to be a very fine transient calculation, is to just decrease slightly that minimum time step that OLGA is able to use. The final thing that we need to do is to have a look in this restart section here. Now, there are a few things that we need to do here. Firstly, we need to change this read file option to on, and then you can see there are two things that we need. We need to input some sort of file, and we need to have the read time. So what this says is what time of results should I pull from this particular read file. So we're going to get this read file from our tutorial 3 start. And the way we do that is to actually go ahead and run a case of tutorial 3. There we go. And what's going to happen is we're actually going to use the outputs from this tutorial 3 case as the initial condition for our restart. So effectively what will be happening here is that tutorial 3 will provide us some steady state condition, and then we're going to simulate what happens when we turn off fluid flow. And that will be the simulation that occurs at the start of tutorial 4. Okay, so our tutorial 3 has once again simulated. Now what we need to do is to again take a look at tutorial 4 start here. Alright, so we can now go ahead and pick that file, and this is going to be our tutorial3start.rsw. And this is just the type of file that OLGA generates once it's actually run a particular case. So we click OK or Open, and then the read time is going to be the end of that particular simulation. So that was a 1-day simulation, so the time that we wish to read this file at is 1 day. Okay, so there are a couple more things that we need to do here. In our integration time, we're going to set this to 80 hours. Say that the time it's going to take for everything to come to some sort of equilibrium is going to be fairly long. Now there is one final thing that we have to do, and that is to change the actual inflow specification. Let's just set our mass flow in our source to 0 kilos per second. So now what we've gone ahead and done is to give OLGA some initial condition that it's going to evolve the entire system from. And what we've done is to turn off the mass flow at the start and to then let it run for 80 hours and see what happens. So we can go ahead and press run batch. And you can see pretty much immediately what happens is that we get some sort of an error happening within OLGA. And again, this is just a simple one telling us that our pressure values aren't quite appropriate, or that OLGA has gone outside the pressure bounds that we wanted to see. So what we have to do in that case is to just open up multi-flash and to expand that table boundary. So if we go ahead and open our black oil with water case, click OK. Then we can go into Table, OLGA, Browse. This is our OLGA tutorial. This is tutorial blackoil.tab here. We can open that. And now the fluid ID, this is important. When you're running these individual transient cases, basically the previous initial condition that you gave OLGA is going to remember what the fluid ID was for that particular simulation. So if it turns out that your table file when you're doing your shutdown or your restart is too small, then you're going to have to just overwrite the name of that fluid ID, because otherwise OLGA will believe that you've put some sort of a different fluid into the system. So again, we'll run from 100 psi. This time let's go up to 5,000. Do 50 points, minus 10 Fahrenheit up to 300 Fahrenheit. And 50 points. We can calculate our table. Yes, we want to overwrite it. And now we can go back to OLGA, and we can just press run batch again. And what it'll do when it actually starts up is to just pull values from that new table which has been overwritten. Okay, so this is finished up. And we should note that now that we're dealing with these transient restart cases and we're running for 80 hours instead of 24 hours, we can expect that these simulations are going to begin to take much, much longer. Okay, so what we can do now is to just verify that that shutdown has worked properly. So we'll create a profile plot, and we're just going to take a look at the flow in the flow line. So our flow rates and our pressure, press OK. So you can see this is our initial condition, and then immediately as we go along in time, this drops off. And you can see that we have more or less zero flow through the system. This is telling us that, yes, our shutdown has worked correctly. And what we can do then is to use this particular case as the basis for the next part, which is looking at our restart. So again, what we want to do is to duplicate this case. And our next case is going to be tutorial 4. Restart. We could also previously have renamed our case here. In fact, we can go ahead and do that right now to save as tutorial 4 shutdown. And what we should do now is to not really touch this again unless we need to run another shutdown case, because in our restart, what we're going to be doing is using the result from that shutdown as the initial condition. So we have a few different things. We go into our restart, we change that initial condition to tutorial 4 shutdown. Okay. Now, this simulation ran for 80 hours, so we have to change the read time, 80 hours, there we go. We can leave our integration settings more or less the same. And then the final thing that we really need to do is to once again turn that mass flow rate back on. So what this is now telling OLGA is that we're going to switch on our flow rate back into the system, and then we're going to let you see what happens for the next 80 hours of flow time. So we can go ahead and verify just to make sure that everything is happy, and then press run batch. Okay, so our restart case is finished. Now what we need to do is again verify that that's working properly. So we'll create another profile plot. Let's just look at the flow line itself, flow rates, temperature, pressure, press OK. And again, our initial condition, nothing is flowing, but as we evolve time, yep, we can see that everything has come back up and we have some sort of flow that is coming through the system. So once again, this is quite encouraging. And it seems then that for this simple case, we have our restart working nicely. So basically, that process of running and making sure that your steady state calculations work, using the result of that steady state calculation to do a shutdown calculation, and then using the result of the shutdown calculation to do your restart calculation, is how we're going to be dealing with our transient systems in OLGA. Now what we're going to do is to just take a look at a more complex case. Okay, so what we're going to do now is to turn to tutorial 3 and complete it here. So once again, what we want to do is to just make sure that we have a working batch simulation from tutorial 3. So we can go ahead and run one of these. Okay, so we can see that our tutorial 3 is still working, so we can stop that. Once again, we're then going to duplicate this case, and this is going to be tutorial 4, advanced shutdown. Okay, so we're going to be basically modifying this in a similar way to what we saw previously. In our options, we're going to need to turn steady state off. In our restart, we are going to have to turn read file on, and the read file we're going to be using will be tutorial 3 completed. Okay. And the read time here, I believe, is 1 day. We can just go ahead and double check that. So in tutorial 3, our integration, yes, was 1 day. Okay. So our tutorial 4, 1 day here. In our integration, again, we're going to decrease the minimum time step slightly. And we're actually going to let this simulation run for 100 hours rather than for 80 as we did previously. Okay, so in the simple case, the way that we simulated the stopping fluid flow was to just turn off this mass flow source that we had. But in this more advanced case, what we have are actually pressure sources. So the way that we can stop our flow in this case is to make use of valves. Now, it seems most sensible to put these valves on the flow lines themselves, because this can then represent some sort of valve near the manifold or at the manifold itself. So this is going to be flow line A valve. This one here will be flow line B valve. Okay. Alright, so the properties that we have to give these things, as you can see down here, we need to tell it where in the pipe, or which pipe the valve is attached to. So in the case of flow line A, we only have pipe 1 available. And then it says which section we want it on section 1. Finally, in our model description, we need to know something about how big the valve itself is. Now, let's just say that we have a 12-inch pipe, so let's let our valve diameter also be 12 inches. Over in flow line B, you'll remember that we actually have 4 pipes, but pipe 1 is the one that is closest to the wellhead. So we again choose this, section 1, diameter of 0.254 meters, and there we go. So this should more or less be complete. Now there is one final thing that we need to do, and that's to tell the simulation what's going on with the closing of these valves. You can see opening up here. Time is 0, opening is 1. So that basically just tells the simulation that initially, and indeed for the entire simulation, the valve should be opened. We want to change this so that initially the valve is entirely closed. Do this for both wells A and B. And then we can go ahead and run our batch once again. Okay, so our shutdown case for this more advanced simulation is now run. And again, what we want to do is to verify that it is actually shut down correctly. So we create a profile plot, and what we'll be taking a look at is the flow in flow lines A and B. Okay. Alright, so again, our initial condition here is that we have some sort of fluid flow. And then as we advance time, we can see that this decreases. But it doesn't decrease all the way. And this is the same sort of thing that we saw in the first simple case. So why is that? Well, despite the fact that we want to be producing oil and gas from our wells to our separator, OLGA just views pressure nodes as being effectively infinite sources of fluid. So what can happen when we cut off the flow from A and B is that we actually get some sort of backflow through the system from our separator. So what we should really be doing then is to chuck a valve on the riser as well and to set that up. So it's going to be on pipe 1. In this case, we want it to be at the end of the riser, so we'll choose section 11. Again, same diameter as the pipeline. Okay, what we also have to remember to do is to actually close off that valve. There we go. And now we can run our batch simulation. Okay, our simulation is completed. And now we can go to our profile plot and refresh that. You can see I've added the pressure in here as well. But now what we can see is that all of our flow rates are 0 and our two pressures are lying directly on top of each other. So this tells us, firstly, that there is no flow, so we have indeed shut down the pipeline, and secondly, that it's at some sort of equilibrium condition. So taken together, this means that yes, we are in a correct shutdown or shut-in scenario. So what we need to do now is to run the restart case. So again, we duplicate case. This is tutorial for advanced restart now. There we go. Save that. And now we just need to make those same changes that we made previously to the simpler case in order to get the restart working. So we need to change the initial conditions or the initial condition file to tutorial for advanced shutdown. And remembering this was a 100-hour simulation, so we can go ahead and change this. What else is there? Our integration time, we'll maintain that at 100 hours. We need to make sure that now, because we're restarting, our valves are going to be opened. There we go. Okay, so let's see what happens when we try and run this simulation. It goes outside the bounds that it is given in the table. And you can see it's actually temperature below the value in this particular case. And this is for wellhead B. So we can say, all right, and let's just open up multi-flash again. And we can open our tutorials. So our fluid or our multi-flash file for reservoir B here, we can open that. And we can go to our OLGA table. Again, we'll have to update this. So reservoir B was our tab file. And our fluid ID, if we go back to OLGA briefly and we take a look, our fluid ID is reservoir B. And again, it's important to keep these the same. So let's have our pressures 100 up to 4,000 psi and 50 points. And the error that we had was around about that minus 20 degree mark, I think. So let's just take our lower bound in temperature down to minus 100 from minus 10 as it was previously, up to 350 points. We can calculate our table, overwrite, and go back to OLGA, where we can once again run our simulation. Let's see what it does this time. Okay, this time we have yet another table error. And we can see now it's getting down to minus 145 degrees C. So when we see something like this, we might begin to think that, well, maybe we don't need to just keep on expanding that table. Maybe there's something more fundamental that's going on here. So if we think about what it is that we're actually doing here, well, we're saying that we had some equilibrated condition with fluid pushing up against our wellheads, and then all of a sudden we just go ahead and open both of these valves to their maximum level of opening. Now, if you think about the mechanical stresses involved in doing something like that, they are quite extreme. So what we can begin to do is to take a look at the idea of introducing valve opening schedules. So these valve opening schedules can be informed by actual experience that you have with these sorts of things by doing some calculation about the mechanical stresses involved. What we're going to do is to just try a couple of different values. So the way we can put in one of these is just by adding in a series. So let's start at time 0 for flow line B, 0, 1, 2, 3, 4, 5. And then we're going to need to give it 6 corresponding levels of openings. So let's start at 5%, go up to 10%, then 20, 40, 80, and 100% open. Now for well A, well, let's just do something similar for well A, shall we? 0, 1, 2, 3, 4, 5. And then we can have again 5%, 10, 20, 40, 80, and 100% open. So you can see down the bottom here it says running. That is because we have not yet closed the OLGA window or the OLGA command window. So if we press enter, now we're again ready to simulate. OLGA will tell you that it's not ready if there's a mismatch in the dimensions on these two things here. So let's go ahead and run our batch simulation again. And so you can see that we don't immediately get any error in here, but very soon thereafter we have another failure. So this time, rather than being in well B, it's happening in well A. So what we can go ahead and do is to firstly just, once again, expand that fluid file that we had. So again, if we go into multi-flash and we open our reservoir A, we can change the table for our tutorial black oil. This was black oil with water. And we had a problem with a low pressure bound, so let's put that to 10 psi, 3000 as our upper, 50 points. And we noticed that we had some problems with low temperatures on well B, so let's decrease that a little bit as well. There we go. Calculate our table, overwrite, and let's have another go at running our batch simulation in OLGA. Okay, so our simulation has completed successfully with these changes that we've made. What we want to do now is to again see how it's actually performing, or what it is that's going on. So let's take a look again at the flow in our two flow lines, A and B, and we'll also take a look at the pressures. Okay, so this again is our initial condition where everything is shut down. Now you can see that as we go along, we actually have this negative pressure gradient in flow line A. And what that then corresponds to is backflow through flow line A. So this is not what we had hoped to see, obviously, because what we're looking to do is to restart to that initial steady state case that we had, where we had production from both of our oil wells. So there are a couple of different approaches that we can take to fixing this, and it basically revolves around thinking or understanding what it is that's going on with this particular system. Now in this particular case, it effectively comes down to the fact that we have 3000 psi driving well B, and we have 2000 psi driving well A. So as these are starting up, what we simply find is that when flow line B reaches this intersection here, its pressure is so high that it is pushing down both flow line A and up the riser as well. So what we need to do is to ensure that we either establish the flow of A to begin with, and we can do this by changing the opening schedules. So we have, over the first 5 hours, restarting wellhead A. We could potentially change the time that we open up valve B to be after, say, a day, and that might give well A time to actually restart and establish its flow entirely. But one thing we can use to absolutely make sure that we don't get any sort of backflow is this check valve. So let's just put a check valve onto flow line A. Okay, and we want to again attach this to pipe 1, and we want this to be at the end of our flow line. The advantage here is that if it's at the end, then flow line B can flow up and into the riser, but it can't flow back towards well A. This is now ready to simulate. We can verify, and we can go ahead and run that simulation one more time and see what happens. Okay, so our simulation is completed, and let's see what the results of that look like. So we can again go to our profile plot. Let's just turn everything back on. And if we reload this, then we can see at the end of our simulation, we once again have the sort of flow that we would hope for along the entirety of our pipeline. So this is interesting because it illustrates that despite the fact that we can get some sort of steady state result out of OLGA quite easily, we can see that it's not necessarily that simple to get there from a real shut-in condition. And in order to actually achieve that final expected steady state condition, we've had to go ahead and make a few interesting modifications to our system. Okay, so that about wraps up tutorial 4. What we've done is to take a look at shutdown and restart for one simple case and one more complicated case. And we've taken a look at some of the troubleshooting that we can do in order to get these things working. Now, in the next tutorial, what we'll be taking a look at is hydrates in OLGA. So we'll be taking a look at transient cases where hydrates are present, and we'll also be looking at the various different prevention or mitigation methods for hydrate that can be simulated within OLGA.